So welcome to part 3 of Simple Physics in your game. Platform game specifically. By the way, if you just wanted to make a spaceship game, something which doesn't involve gravity or a whole lot of friction from having to walk on surfaces, then you're good to go. That's all you need to know. You've got basic physics there. We're just now applying this to a planet, and we have our collision on our ground. Just type this. Bring the cursor over. There we are. And we have a solid surface, but there's something, he moves a bit, Mario doesn't move like this. It's not so stiff. Mario speeds up and then he slows down, and this guy just moves linearly. Remember the same problem we had with falling? We were moving linearly, just straight down. We didn't slowly, gradually get faster. It's the same concept. See here, we're modifying our velocity, and we're using our velocity to add to our position rather than adding to the position directly the same amount every time. We've got to do the same thing here to the position. Currently we're still adding to the position directly every time. So we're for gravity, for falling, for the y velocity, we had gravity being added. We're going to need a walk velocity. So first off, it could be x pos equals x pos plus x vel, but I'm going to use the shorthand version of this. Same functionality. This does the same thing. If I go use a special sign called plus equals, which means take this value and add that to it and set it to the results. So x pos equals itself plus x vel, which of course is wrong. For if we want to move left, we want to subtract. Right, and plus equals x vel for moving right. Now x vel is 0, which I seem to have added already, as you may have noticed. What are we adding to x vel to make it bigger and bigger every frame? Well, let's give walk speed. We'll call it walk velocity, walk vel. And I don't know, gravity's pretty fast. We'll make it the same as gravity right now. And let's see what happens. So we're going to add our walk velocity to our position every frame. We have an error. Syntax error near 01. What's that mean? Line 7. Oh, forgot the equal sign. Do that again. Okay. I'm going to start walking. Not a whole lot happens. Why? I think I forgot a step. X pos equals minus equals x vel. This is backwards. Sorry to mislead you there. We want to do the same thing we do for y, which is just add. My mistake. We just want to add the velocity to the position every frame, and we control it via the velocity. So that's what we're doing here. We're no longer controlling the position directly. We're affecting the velocity, like we're giving it a push. We're applying a force, and then we let the physics, which is these two lines here essentially, take over. So we now control our objects by applying forces, and that's how we use our physics system. And our physics system, this is our physics system here. Pretty simple, huh? 2 lines of code. I like it. So that's how you know nothing can go wrong, because there's a bug. Maybe it's in this line or maybe it's in this line. That's what I'm talking about, simplicity. It's the way I like things. So let me see. Yes, we want to add to the velocity. We're just modifying the velocity. So x vel plus equals, no, minus equals for left. The walk velocity. And of course we'll copy that, put that in plus. Now we should see some action. Let's save this. What should I save this as? I'm just going to save this for the purpose of the video. I'm just going to number it for my own reference to be something that is above what you saw in the last video, but it's alright. I'm going to start walking now. Just move this cable. What happens? Let's have a look. Hey, whoa, I can't stop. Hang on. I go press the other way. Whoa, I'm sliding. And the thing is, already I'm going to press the key, I'm going to hold it. I'm going to faster, faster, faster. But I don't stop. I mean, that's a problem too, the fact that you just get faster and faster and faster. What we have here is he's in space. We have applied gravity, but that's only on the Y. And we've got collision, but this velocity is working like he's in space. And if you want a space shooter, this is all you need to do to your X and Y velocity. You just have to be like, whee, hoo. So I'm going to press and I'll let go. He's still going. I've got to press the other way to apply some velocity in the other direction to stop. Just like in space, if you fire your jets and you start moving in one direction, you don't need to keep your jets going to continue that movement. But if you want to stop, you've got to fire your jets in the other direction to stop. And I can never really stand still because he's on ice, basically. There's no friction. That's what happens when you're on ice, no friction. Well, sounds like we need a bit of friction. And just to reiterate, I'm pressing the key and I've let go and it's still going. I've got to press the other way. Okay, so sounds like we need some friction to slow us down. So, now I could have a friction value that I subtract from the velocity, but velocity is sometimes positive, sometimes negative, depending which way you're traveling. And then you want to subtract the right amount that if you're near zero, you don't then go the other side of zero, and your character starts. It complicates the code to try and check for that, and if you don't check for that, you get they jitter back and forth when they're just about at zero, and it's a bit annoying and complicated. And there's another cool trick, another one-line trick I'm going to show you. So every frame we're applying gravity to our Y velocity, and every frame we're going to apply some friction to our X velocity. But the way we do it is we're going to just divide halve the velocity every frame. So it'll always approach zero no matter which side of zero it's on. And this now becomes our friction value. So instead of putting a number in the code, friction, I'll make a friction value. By the way, I'll put this friction here. Friction, but it's 2. It doesn't mean anything to anyone else. Yeah, I'm using number 8 here. I could go around and put tile size, but because of the nature of Pico, it's so common. Everything is 8, so when we see 8, we know. It's just one of those places where you're going to know the rules before you break them. Just give me a sec. You probably won't see that anywhere else. You're probably going to have a tile size because it's going to be very arbitrary in your other engines. But in Pico, it's all 8. So anyway, we're about half time. So let's xvel divided by 2, halving itself every time. So it's always going to hit 0 at some point. That didn't work. Divide equals. You see, if I was using a divide sign, it should have been equals xvel equals xvel divided by friction. That's the expanded version. xvel equals itself divided by friction, which you can also write shorthand like that. So run. Now we'll move. We can't fight the friction. It's a very sticky floor. So let's see. I'll have to lower the friction factor. Instead of dividing by halving each time, obviously I wouldn't reduce it to 1 because you divide something by 1 and it's the same thing. So I'll make it 1.5, so it's less than half, but not 1. We'll see what happens. Oh, and we fell through for some reason. Now that you've finished laughing at me, I'll change the real variable. There we are. Okay, it's a little bit faster. Now, excuse me, the question is, do you make, when you've got some, a force, and you've got another force acting against that force to slow it down, whether it's friction, jumping, gravity, and all that, you've got the two choices. You've got, in the case of this walking on the ground, do I make myself stronger to overcome the friction, or do I make the friction weaker? And you kind of get different results depending which way you go. You kind of adjust the curve of acceleration depending on what. So you just got to get something that feels right. So we go, hey, and he slows down. And we're, hey, and he slows down. It's a little bit too glidey for my liking. How about just 1.3? What's that like? Well, I think we may have to make him stronger when he walks. Oop. It's not bad. It's going to have to be stronger, I think. Walk velocity is now going to be 3.3. What do we get? That feels good. That feels a bit Mario-esque, actually. You know? So I'm going to leave it there, because the next thing I really want to do, and I can't help myself, I just want to jump right now. I want to jump to test out the jumping. So I'll leave it there, and I'll see you in part 4.